I promised that if I ever got a Crossfire setup running Mavlink, I would make hopefully a better video than you can find on the internet how to do it. I'm going to do it for the F765 wing. So up on the screen I've got the data sheet for the 765 wing. What we're talking about for my setup here is these two pins right here, transmit and receive, UART 4. I am going to talk about these pins just because I'm going to give you a complete solution, but this is really all we're talking about right here. These two pins are how Mavlink data is transmitted from the Crossfire Nano Diversity receiver through the transmitter to Mission Planner, whatever you want to do with that Mavlink data. I bet it works in Q ground control also. Whatever you want to do with the Mavlink data. So what we're talking about here straight up is TBS Crossfire Diversity Nano Receiver. I like it. These pins are big enough for me to solder to. I'm going to try to solder to these next time. I think if I use the wire that comes with it, I can make little pigtails at the very least. This is the transmitter I'm talking about, Crossfire Micro TX version 2 that has Wi-Fi built into it. And this is what I was talking about. Here's that receiver with those pins, solder pads on the flight controller. You decide if you use pins or not. It's a straight through connection. Whereas we're going to set up inside the software on the Nano receiver what the function of these 4 pins are. We're going to set them up such that I've got my transmitters on these 2 pins right here, going to receive right here on these 2 pins, so I can just make a straight through cable for them. Actually, I'm going to show you where you can buy straight through cables for them. I'll make this simple. And I am going to talk about the full wiring here. I'm even going to use the color code for the first 5 wires of what I'm going to show you. I couldn't do it for the white wire on the 6th wire because it disappeared into the graphic. Well, didn't here over the blue, but I could have described it to you. There's a white wire going from here to here. In this case, it looks like a purple wire. And the only thing we've got there, we're going to set this transmitter up in its software so that transmit, and receive on 2 UARTs. We're going to use this UART for CRSF, or we could just use its transmit pin only for PPM or S-Bus. There's a multitude of things that could be done if you're using these 2 pins, either one or both, for your control channel. I'm not going to go deep into that because this is a Mavlink over Crossfire video. So this is what we're talking about right here. This is going to be a Mavlink transmit. This is going to be a Mavlink receive. Going right here. Okay. What I did with this, I'll just show it to you. I went up on Amazon and I bought 40 of them, I think. No, it might have been 20. I figured if I cut them in half, I'd have 40. That'd be enough. These are straight up machine-made 6-pin DuPont connectors. If you put pins on these 6 pins right here, then you have a straight up 6-pin connector here with a little bit of a change to those wires. I'll show you on the pins. You can't see it well. I can't point to it well in the diagram, but the black wire isn't the first wire in the 6. It's the second one, and the red wire is the first. So you got to switch these 2 wires around, and after that you have black, red, yellow, blue, green, and white as a color scheme. black, red, yellow, blue, green, white. Okay, I'm colorblind. It's purple. Shoot me. That's why I did that. I paid $13, and I figured if I cut these things right in the center, I would have factory-made connectors that I could then, and that's what I've been doing. When I get in a flight controller, a VTX or a GPS or whatever that has a special connector on it, I cut these in half and I use one side of this on the flight controller with 6 pins frequently, and I use the other side. I just solder them together in the proper order with that special purpose GPS connector, airspeed connector, VTX, whatever. Just worked quickly for me. In this case, we're going to be taking 6 pins to 6 pins. So I soldered up 6 pins down these solder pads right here, right through here, and I soldered up 6 pins right down through here. I use these connectors. We'll look at it specifically on the bench now. This is the bag that I got. I've still got just a bunch of them in there to cut in half and make up custom cables, or use whole if it's a 6 pin to 6 pin. I want as many pins connected as possible without any breaks in this plastic part so that they stay connected better, have less chance of vibrating loose. The problem with this, as you can see, it is as it comes from the factory, it's red, black, yellow, blue, green, and white. Now what you have to do, I think everybody knows how to do this, so I'm not going to go deep into this. I raise up the little plastic latch right here with a set of tweezers, and I pull out the black and the red, and I swap them around. Then I go to the other end, and I do exactly the same thing. I pull out the black and the red, and I swap them around. So I've got exactly what I show on the screen right now in the connectors on each side, where it's straight through: black, red, yellow, blue, green, and white. Black, red, yellow, blue, green, white. And so they plug right across those pins, with the black on the ground on the receiver and the black on the ground on the flight controller, and your wiring is finished. There's a Diversity Nano with pins soldered to it. Black, red, and then I've got 4 signals that are all white. Whatever. If you had a bunch of colors, and I actually have the colors here, I could make these the proper colors. I'm not going that deep into all of this. I soldered pins on the F765 wing, and these 6 pins right here is what we're talking about. With those pins swapped around in that connector and plugged properly into those 2 sets of 12 pins, 6 on each side, you have that receiver connected to that flight controller perfectly. The ground and the voltage you don't have to worry about. The flight controller is going to supply 5 volts and ground to that receiver. Now we have to come in. I'm going to show you how it's done on the TX16S. It used to be SE, but it's a straight S now. You go into the system menu. I use TBS Agent Lite. I've been using my other radio. This might not be upgraded enough, but I guess it is. Oops. I don't have a receiver turned on. Let me turn on a receiver. While we're at it, we'll just plug in this USB. Let it get everything fired up. And look, a Crossfire Nano Diversity receiver just appeared in the list. I'll select that. It'll read in its stuff. In the output map, you'll see I have output 1 assigned to CRSF transmit, output 2 assigned to CRSF receive, output 3 assigned to Mavlink transmit, output 4 assigned to Mavlink receive. While we're in here, I will show you the other setup items for the radio and the transmitter. We'll just go into the transmitter real quick. Under radio settings, this could be a problem. You could force telemetry to make sure it stays in 150 hertz mode, because if it drops it into 50, you lose telemetry. That's a little deeper. I haven't proved that one yet. I'll have to play with that one. So basically there's nothing to do in here. Right here, your Mavlink, you want it on. You can turn it on and off in here. I have never gotten this screen to do anything, the Mavlink mode. That's fine with me. That's all you have to do in there. Inside the, let's see if there was something else inside the receiver. I set telemetry on here, of course, and I also set RC by Mavlink on. I think that's what actually would let me use a joystick on Mission Planner to fly, so that's why I've got that on. So I do turn that on. Yep, that's the only thing in there. Oops. Inside, come on. Inside the Wi-Fi, which you can get to here also, you have to attach the Wi-Fi in the Crossfire transmitter to, I'm attaching it right now to my router in my house. Let me look at this real quick. Yeah, okay, good. It doesn't show my router name or its password. You have to enable this to connect it to a router. You have to scan for, and I can scan for it, there's Netgear, but I'm not going to show the password. You type the password in, click connect. You can find out if you successfully connected by coming over in this about screen. And if you have successfully connected, it will tell you what you connected to and what IP address this module in the back of here has. That's why I connected it to my router. My home router, and most home routers have a DHCP server in them, and that dynamically serves IP addresses. That's how this 192.168.1.17 got in here. I haven't connected it to my notebook yet, but my notebook doesn't have a DHCP server in it, so I'm going to have to find a way to set a hard IP address or something in that. I'll be addressing that soon. This is why I connected it to my home router, because it automatically gave out that address. The other thing in here is the Mavlink. This now doesn't say UDP anymore. It says TCP server on and has a port value. I'm just going to stick with those values. So now I can actually lay this radio down here. We'll go back to the screen. We'll go to Mission Planner. We'll go in with a USB connection to, it's actually a airplane, Skyhunter I have across the room, and we'll connect to it with a USB cable, and we'll come in here because what we want to talk about is this portion of the data sheet. Remember, we're using UART4 for Mavlink. I wish this chart was better done, but it's not. Here's UART4. This column is for the hardware. This column is what Ardu wants associated with those UART ports. And you can see, although Ardu is 0 through 6, I think just by happenstance on this chart, I don't know why Maytech did that to make them look good. I would have put these 1 through 6 and made these be all random. But you can see serial 1 is actually UART 7, serial 2 is actually UART 1, serial 3, 2, serial 4, 3, serial 5, 8, serial 6, 4, serial 5 not supported in the F765. 6 is actually 7 on Ardu, but they didn't put that in here for some reason. If you want to change the RC input UART, that's why I'm telling you about CRSF on these 2 pins right here, then you're talking about serial 7. For the current version of Ardu Plain, Ardu, whatever, it comes out of the box with serial 7 set up to do CRSF, PPM, SBus. It's all automatic. So we got UART4 we're hooking to. That's going to be serial 7 inside Ardu Plain, which is what I'm using. So if we come over here and search for serial 7, oops, that's not what I want. I want 6. Boy, my brain's still mush. The default for this when you install the firmware is -1, none. Default for this is 57. For 57600, you have to change the serial 6 protocol to 2 and the serial 6 baud rate to 115. Write it out, reboot your platform, you'll pretty much be golden. After that, armed with that IP address that I showed you from the transmitter, we can come into TCP connection. This doesn't seem to allow me to change the baud rate here. If there's ever an opportunity to set the baud rate, I would suggest 115.200 TCP connect. This is that IP address 192.168.1. 0 through 255 is a non-transportable address. The whole shooting match. 255. All the routers on the face of the planet and internet servers are told, don't you transfer that from one site to another. That's for internal use only. That's why a lot of this gets set up on these first 3 digits. You might notice a lot. This happens to be 17 for me. That's what my router assigned it and what it showed me in the screen on the radio. I'll click OK. 8888 is the port that was assigned in the radio. Click OK. Everything starts percolating. You can see down here link quality with the ground station. I like 70 or above. Some people say 60 and above. will be showing in the field what 60 and below will give you. Give you a headache is what it'll give you. This is going to take some time right here. This will eventually, and it not like 10 minutes, it will take just a short bit of time. See, now it's starting to read in the parameters, and you're going to see some failed reads, already gots. That's retries. There's a lot of retries going on here. There's a lot of drop packets going on here, even at 70%, but it's a usable connection. I can't show you how it works perfectly as well as a USB cable. I can show you I have some packet switching radios for telemetry that work at 100% consistently. I haven't showed you, oops, that's because of a different problem. But basically everything, the screen is still going across up here reading in perimeters, believe it or not. And it actually read them all in. And if we look at the link status, this is what I'm talking about. This shows a 77% link quality, whatever. It's got close to 900 bytes per second transfer. With a USB cable, it's only 1.5. So it's quite high in throughput. It is functional. You're not actually going to give control links right and left, up and down. Oops. Yeah, you would be if you're flying with a joystick attached to your ground station. Without supplying flight controls like you would with a joystick, you're just going to be doing like fly to here at a certain altitude on here, or you're going to be over in this screen, arming, disarming, returning to launch, setting auto mode, just about everything you can do here. You don't have to have a 100% real time. There can be a lot of lag in your ground station. You don't want lag in your video transmitters. You don't want lag in your RC transmitter in your hand. But as far as this data coming down to Mission Planner, it can be 5 minutes behind as long as it all comes in. With a lot of packet loss, which one of these does show you packet loss right here. It could take some time, but it is functional. You know, if for some reason the radio in my hand can no longer transmit return to launch, I could click return to launch right here. And see, the platform across the room has gone into return to launch. It could take 2 minutes for that to get to the platform. Is better than nothing if it's a flyaway now, and due to link quality from distance or whatever, you get your platform back. As far as whether we use telemetry or not, that's a whole separate discussion. But for those who do want to, this is the way you do it with ArduPilot. I hope I explained it right down to the wiring. I think I'll put this link to the wires for Amazon in the details of the video. I mean, that was just easy for me. So I don't know how to explain it any better. How to do Mavlink via Crossfire. I bet I didn't say it was a perfect link, but this is the best I've come up with. This is functional. In my humble opinion, it's flyable. Also, in my humble opinion, at this low of a link quality, it's not going to be 100 feet, 500 feet before it deteriorates to where it goes out. That's going to be much worse with an airplane type platform where it's boogieing. Could be up to 100 miles an hour away from you. With a quadcopter or a hexacopter, well, you can put it in altitude hold. You can move it out 10, 20 feet away from you and see what happens. That's all that testing and stuff's up to you. I just promised if I ever, oops, I just promised if I ever got it working, I would do a halfway decent video on how to do it. I don't know what else I could add. So I'll just say thank you. Have a good one.